Agnel. So the first one is polypropene, because I told you the question will be, they will give the structure of the polymer and ask you to write the monomer. So polypropene. So first the easiest way is you write the monomer and write the polymer. Okay. So propene, polypropene, the monomer is propene, isn't it? And so you know that how do you write the polymer n times, and we open up the double bond, and then the other group is brought down, isn't it? So CH3 is brought down, open up the double bond, and n times. Understood? This is polypropene. So the question will be, they will give you this. You will not have any idea if you don't see this. So this is polypropene. So the question will be, ask you to write the monomer. Monomer is propene. Clear? Is it okay?
Yes, ma'am.
So next one, we will go to the next one. Any doubt on this?
No, ma'am.
Okay. So the next one. The next one is polystyrene. So styrene, can anybody tell me the formula of styrene? Fast.
C6H5CH2.
Very good. So this is styrene. C6H5CH double bond CH2. Yesterday we learned for Buna S, isn't it? So polystyrene, we will bring the C6H5 down, open up the double bond n times. So C6H5, open the double bond n times. Clear? This is polystyrene. So if they give the polymer like this, then you should understand it is styrene. Monomer is styrene. Doubts you can ask, otherwise next polymer. Okay?
Yes, ma'am.
Who is having doubt?
No doubts, ma'am.
Who? No doubts, okay. Now next one is polyvinyl chloride. Polyvinyl chloride. PVC. Polyvinyl chloride. So vinyl chloride, so you should know that from the name itself it is vinyl chloride. So already, see, those who do not know what is vinyl chloride, you can write ethene. This is ethene, and one hydrogen of ethene is replaced by Cl. All of you write ethene first, one H is replaced by Cl. This is called vinyl chloride. Vinyl chloride. So n times this polymerizes, and as you know how to write the polymer, we will bring that Cl down, open the double bond n times, isn't it? So CH2 CH Cl n times. So this is polyvinyl chloride. Clear?
Yes, ma'am.
Okay. Next one is urea formaldehyde resin. urea formaldehyde resin. Okay. So urea, anybody knows the formula of urea?
Ma'am,
NH2.
NH2 CONH2.
So this is from the name itself. Urea is one monomer N times and the second monomer is CH2O. This is a polymer you just learn. H is removed. CO, NH, CH2, N times. If you see like this is a urea formaldehyde resin. Okay, so the changes H from each NH2 is removed and O from CH2O is removed.
Ma'am? Ma'am, in the group, Agnel is telling he's having trouble with joining the meeting, ma'am. In the WhatsApp.
What trouble he is having?
I don't know, ma'am. I think the network is.
Data pack expired.
Yes, ma'am, that's what he's writing.
Expired, he knew that it is going to get expired. He could have recharged. Okay, so this is, see, if you don't go through this table, you will not understand. If you see NHCO, NH itself, you can remember it is a urea formaldehyde polymer. Okay, clear?
Yes, ma'am.
Okay, next one. Next one is a frequently asked question. This is glyptal. This is polymer's name. This is glyptal, and terrene or terline, all of you write first. Tell me the monomer of dacron, terline or terrene. Fast, who can say? Who will say first? Monomer of terline.
Ethylene glycol.
Ethylene glycol and terephthalic
Ethylene acid.
Isn't it? You remember? So CH2OH. So first I will speak about phthalic acid and terephthalic acid. Okay. So phthalic acid is this. Terephthalic acid, you remember, para position is the second COOH group. This is terephthalic acid. Terephthalic. This was used in this was used in terline, right? So now I am going to. So that was used in terline. So now I am going for phthalic acid. This is terephthalic acid. So phthalic acid is this. One COH. The next position is the COH. Can be here also, there also. You understood? So the difference between this is phthalic acid. The difference between both the two are the position of the second COH group. So here in the para position, here in the ortho position. Is that clear? So this is phthalic acid. So in glyptal, we take ethylene glycol and phthalic acid instead of terephthalic acid. Any doubt you can ask, then we will write the polymer. You write in the book the two.
In phthalic acid, it is in the ortho position.
Yes.
Okay.
Terephthalic acid, it is in the para position. You write and keep both. So the difference, if you know, then you can, we can write the polymer. Okay?
Yes, ma'am.
Okay, now I will write the polymer. So, ethylene glycol, CH2OH, CH2OH. Now this phthalic acid, I will be writing like this. You can write in any way. So, written down. and I want to write the COOH groups here. You understood why I wrote? Because water elimination is here. So near this OH group, I wrote the first COOH. Next is in the ortho position. So this is phthalic acid. This is glycol. Is it okay? So the
Yes,
polymer
ma'am.
N number. Okay. So in the polymer, I will not write H. O dash. CH2, CH2, O, C double bond O. Here. Or same way I can write. Instead of that, I will write, otherwise you will get confused. Here, C double bond O. Here, I will put only C double bond O. C double bond O, then N times. You understood? This is gliptan. Any doubt on this? All of you understood? Only thing, you write like this, and you know that OH we will not write, and write in this. Very clearly seen it is in the ortho position. Last year they asked, they gave this polymer and asked to write the monomers. Any doubt?
No, ma'am.
Okay, all of you understood?
One second, can you show the board? Yes, ma'am, done.
And others, Naomi, you understood?
Yes, ma'am.
Tinmaya,
Yes, ma'am, understood.
Jay,
Yes, ma'am.
have you understood?
Yes, ma'am.
Okay. So that is it. So the question is more than write the reaction. The question so far used to come, they give the polymer and ask you to write the monomer, and sometimes with the uses, two uses. So you learn. This is a theoretical chapter, the use and all you have to learn. And so that is about the polymers. Okay. So, okay, so Shashank, are you there? You joined? Shashank, are you present? Or the same story? Shashank, is he there? He joined the meet. Oh, you are there. You can hear me? The net issue solved? Have you solved the net issues? Can you switch on the mic and answer me? Shashank? Can you see the board? Can you hear me? Very slow means, did you see the board, what I wrote? Are you able to follow? Shashank? I can see, but sometimes you can see the board, na? And you can hear my voice. Am I audible? So do one thing, Shashank, you keep the textbook open with you. So even if you cannot see the board, you can see the textbook and then text the doubts. Okay? you see the refer to the textbook, and as far as you can see the board, there is no problem. When you cannot see, you refer the textbook, and any doubt is there, or if you are not able to understand, you can text. Or after the class, when the other children go, you can come and ask okay. So you can ask the doubt, okay? So only Agnel is absent today. So, okay, children, that is about the polymers, and we will go to that. I said in 2 or 3 exercise questions. Remaining are very easy. And some children, I am very happy. Some children are, even if I did not say the chemistry in everyday life, they wrote the exercise questions in the notebook. And so I am very happy. How many of you, I know that Palak did that. How many of you have written the exercise questions in the notebook? Classwork.
I have written one.
Very good, Vishnupriya. Then Prashant wrote. Good, Prashant. Palak, I know that. Akhila, okay. So Priyanka, some children are very sincere. They are writing on their own. Abhishek, oh, good. Saurav, some of them do everything, okay? So even though the most of the questions were direct, it is a practice. And polymers also, it is a small chapter, but then all the things, all the topics are questions. So here in polymers also you write and keep, okay? And neatly write this classwork during inspection and all, ma'am, in between the classwork checking will be there. So maintain the classwork, and those you can write the classwork, okay? So the exercise questions which I felt, see the direct questions I am not saying. And the question number 15.6 yesterday, 15, you take the exercise question 15.6. Yesterday Anand asked. So the polymer, you can see NHCHR N times. Is it a homopolymer or a copolymer? Here it is a homopolymer. You cannot see 2 monomers there. You see the structure, isn't it? So that is 15.6 is a homopolymer. And then 15.7, it is a direct question only. They asked in which class?
How are we saying it's a homopolymer?
Homopolymer, not a copolymer. Copolymer.
No, how are we telling that?
You see the
CHR is
structure,
given, right?
see the structure, na? So here you cannot have 2 monomers in that structure. So if you see that it is an amino acid only, see, I'll go to the board. Yesterday, we learned about glycine, amino acid, isn't it? CH2, NH2, COOH. You remember glycine?
Yes, ma'am.
Okay. So, then this is the first amino acid in the series. Other amino acid, there will be one H will be replaced by an alkyl group. Okay. And based on the difference in the alkyl group, this R is in general. This is the general formula of an amino acid. And different amino acids, the difference is in the R.
Okay,
Understood?
ma'am.
So
Yes,
there is no other, only one monomer. So it is polymerization of this CH, R, and NH. H will be removed. CO, OH will be removed. So it is a polyamide only.
Okay, ma'am. Got it.
Okay, so from the structure, anyway for you, they may not give you compounds other than polymers, other than the polymers given in the book or in the exercise questions. So if you look at the structure, you will be able to understand homopolymer or copolymer. If a chance of 2 monomers, you will understand in the structure itself. Like Buna S, you will understand that 2 types are there, isn't it? Buna N, Buna S, these are all copolymer. Terylene, nylon 6X, isn't it? Whereas nylon 6 is not a copolymer. There is only one monomer, like that. Okay? So 15.7, in which cases the polymers are classified on the basis of molecular forces? Who can tell me fast? Molecular forces.
Elastomers,
Very good. Elastomers.
thermosetting, plastic.
Who is this? Smart.
Arbaz.
Who?
Arbaz.
Good Arbas. See, this way I want. If you learn and come, then you can answer fast. No? So, elastomers, fibers, thermoplastics, thermostatic plastics. So, the questions are easy only. So, what is the doubt? In the table will be asked only the monomer or structure. Normally in the board they give the structure also, structure of the monomer also. That is another possibility. Okay. So last year, in fact last year they asked the name and structure of the monomer. It was mentioned like that. Name and structure. Structure also they will ask. Okay. And so then the next one, 15.14, I told you the answer yesterday. How does the presence of double bonds in rubber influence? That I gave you. And I don't think any other question is there. So if at all any question is there, you will be writing the answers in the text in the notebook, then you can ask. Okay, 15.4. 15.4 is how do you, yes, 15, good Naomi. 15.4 is how do you explain the functionality of the monomer? Functionality of the monomer is the number of binding sites. Okay, you write, I will give you the answer. All of you write 15.4, functionality of monomer. Functionality of monomer is, good, Agnel came. Got data? Good, Agnel. So all are present. Okay. Now write. Functionality of the monomer is the number of binding sites in a molecule. Number of binding sites in a molecule. Have you written?
Yes, ma'am.
So example, ethene. How many binding sites are there? 1. Isn't it? Ethene, 1. And butadiene, how many are there? 2. Isn't it?
How 1 to 18?
Butadiene, 2 binding sites are there, no?
So for 18, how 1, ma'am?
There is only 1. I will go to the board. This is, we will remove this double bond and binding site is only 1, no? So if 2 functional groups are there, binding site will be 2. If 2 double bonds are there, binding site will be 2. Understood? This is the binding site.
Okay, got it.
So that is about the polymer chapter. Any doubt in this? We will go to next chapter. Haloalkanes and haloarenes. You can ask any doubt is there, you can ask. So children, we will go to the next one.
Ma'am,
Haloalkane.
15.18, ma'am, in the exercise.
Okay, I'll open that and see. 15.18. Oh, identify the monomer in the following polymeric structures, isn't it? Monomer, you have to see. Out of that, 2 questions are there, isn't it? First one I will write. Second one, can you identify what is the second one?
Ma'am, melamine, no?
Melamine
So the first
plus
one I will write.
polymer.
First I will write, okay? So this is the polymer. Okay, so from the structure we can take. See, the functional group, this is a dicarboxylic acid. Can you see? So the first one is CH2, 8 times COOH, COOH. This is the first monomer. You agree? Second monomer is a diamine. So the second one is CH2, 6 times NH2, NH2. Got it?
Yes.
So from the monomer easily, from the polymer you can get the monomer. In some cases it is not possible. And so like nylon 6 and all, you should know the reaction. Isn't it? Caprolactam, you cannot guess. Otherwise it is easy. They will ask from this only. Whatever given in the index, in the exercise and in the book. Okay? Those who have not understood this, ask me now.
Once more, please.
What is?
Once more, please, ma'am.
Okay. So this was the polymer given, structure given in the question. And they asked you which are the monomers. So if you look at the polymer, you can see 2COOH. OH is not written. So this is a dicarboxylic acid, this one, this much part. You look at the polymer. And the next one, H of NH2, that means this is a diamine. So what you do, you add OH here, and here H, here H. So you will get the monomer. So OH here, CH2 8 times COOH, here OH, COOH, and here H and H. Clear now?
Yes, ma'am. Thank you, ma'am.
Okay. Anybody else? If you are not able to understand, you can ask children. Clear the doubt and then we will go ahead.
What is the first polymer, ma'am?
What is next polymer? We already learned, Najay. The next polymer is melamine. Melamine formaldehyde.
First polymer in this question. That
This is the first polymer. This is the monomer. Monomer you are asking?
yes, ma'am. Monomer, sorry.
What is the name you are asking?
Yes, ma'am.
Name, see now the common name, it is like you can say common name you cannot see the till adipic acid and all we know the common name. You can IUPAC name you can name it, and the CH2 8 times, isn't it? So you can say octane dioic acid. IUPAC name you can say. 8 carbon atoms are there, isn't it? 8 octane, it is like
10 carbon atoms.
10 carbon atoms are there, isn't it? So decane, isn't it?
Dioic.
Decane dioic acid. Okay. So this is hexamethylene diamine.
What about the position of the carboxyl group, ma'am? 1,
1,
10 should we write it?
It is 1,10.
So 1, 10
Decane.
okay.
Decane 1,10 dioic acid.
Okay, ma'am.
Okay. Any other doubt?
No, ma'am.
Okay. So the next chapter, haloalkanes and haloarenes. So first, what are they? I will explain. So from the name itself, last year you learned hydrocarbons, isn't it? There you learned alkanes, alkenes, and alkynes. So here, out of that alkane. So we will take this alkane, ethane. And arenes is benzene compounds, isn't it? Benzene. So arenes are aromatic hydrocarbons like benzene, toluene. These are arenes. So haloalkane, the first one means one hydrogen is replaced by a halogen. So this is haloalkane. And haloarene we will take. This is an example of haloarene. From benzene is C6H6. One hydrogen is replaced by a halogen. So you got an idea. Now in other words, we are going to learn about the haloalkanes, halogenated alkanes and arenes. Or you can say organic halogen compounds. Clear this much? So this is aliphatic, this is aromatic. Both we will learn about haloalkanes. Any doubt you can ask? Can you repeat the starting? Okay. Prashant, the name of the chapter is Haloalkanes and Haloarenes. I just explained what are they. So alkanes, you know that alkane. So I wrote an alkane, CH3, CH3. This is ethene. This is an alkane. And one hydrogen of alkane is replaced by an halogen. X can be chlorine, bromine, iodine or fluorine. Okay. So then you get haloalkane. So this is an example of haloalkane. Haloalkane. And so next is haloarenes. These are the topics. Second topic is haloarenes. So arenes are aromatic hydrocarbons. Example, benzene. Benzene is C6H6. So if I replace one H by halogen, I will get haloarene. So this is an example of haloarene. Clear? Okay. Any other doubt? Is it okay? You can ask children. It will be little difficult. If you don't follow, you can ask. Isha, you want to ask something?
No, ma'am.
Okay, Prashant, is it clear? Okay. So, next topic. Classification. There are different types of haloalkanes and haloarenes. So, classification. The first classification is based on the number of halogen atoms. Okay, so I will give an example. If one halogen atom is there, it is monohalogenated alkane, isn't it? So there are two, you can see based, it is a dihalogenated compound. And if three hydrogen atoms are there, it is a trihalo compound. So based on the number of halogen atom, you can classify into mono, di and tri halogen derivatives. Clear? So aromatic, this is aliphatic. Is it okay?
Yes.
Okay, so now aromatic. I'm going to draw. This is chlorobenzene, one chlorine, and this is dichlorobenzene, isn't it? And you can say trichlorobenzene. And here, so this way, based on the number of halogen atom. This is anyway easy. You see the number of halogen atom, you can classify. Now the next one, questions are coming. And so next one is based on the, see, there is, I will take one haloalkane. Now the next classification is based on the hybridization of carbon connected to the halogen. Okay, so this I will do, if you are not able to follow, I will expand this structure.
SP3, ma'am.
SP3, see, because single bond means SP3. So base here the carbon connected to chlorine is this carbon, isn't it? So this carbon, the hybridization is sp3. And then there are some haloalkanes in which the haloalkanes and haloarenes in which the carbon connected to the halogen is having sp2 hybridization. So that is the classification. All of you understood? Classification is based on the hybridization of the carbon connected to the halogen. And so there are two classifications. One is the carbon connected to the halogen is sp3 hybridized. And the second classification, in those haloalkanes and haloarenes, the carbon connected to the halogen is sp2 hybridized. Clear? So,
Yes.
first one we will go to the first one. Is it okay, Prashant? sp3. Okay. So first one is carbon connected to the halogen sp3 hybridized. So here the classification, the first classification, primary, secondary. This you have to write down, okay? Are you writing down? Secondary and tertiary alkyl halides. The first one is this, primary, secondary and tertiary. Are you writing down, children?
Yes, ma'am.
Yes, ma'am.
So this I will say, first I will say primary, secondary and tertiary, okay? This is an example of a primary alkyl halide. How do you know? The halogen is connected to one alkyl group. Which is the alkyl group? CH3CH2 is the alkyl group. Or in general, you can say RCH2Cl or RCl. Okay. So another example is CH3Cl. Only one alkyl group is connected. R group. You remember R, capital R. See, alkane is RH. For example, methane. And if one H is removed, you will get an alkyl group. So here the alkyl group is CH3. You remember this? Alkyl groups.
Ma'am, the board is not seen.
This much you saw? This you can see?
Yes, ma'am.
Yes, ma'am.
So alkyl group, all of you know what is an alkyl group? Everybody knows what is an alkyl group?
Group formed by removal of hydrogen from parent alkane.
So alkanes we learned alkanes. So we say general formula RH. For example, CH4, C2H6. If one H is removed, you will get an alkyl group. So example, here one H is removed, you will get a CH3 group. If one H is removed, you will get a C2H5 group. C2H5 is the same as CH3CH2. Isn't it? This and all we learned last year. So R is an alkyl group obtained from an alkane by removing one hydrogen. Is it okay?
Yes, ma'am.
Okay. So we are coming back to our classification. So primary, how do you identify a primary alkyl group? One way of identifying is, see, this is also a primary. So there is only one alkyl group connected. And normally, except the first one, normally the primary alkyl halide, it is the carbon will be CH2, Cl, CH2, Br, CH2I. Then it is a primary alkyl halide. Understood?
Yes, ma'am.
Now secondary. So primary I can say secondary. Secondary is I can say CH3CH, CH3Cl. This is an example of a secondary. So how many alkyl groups are connected to the carbon? 1, 2. 2 alkyl groups are connected, isn't it? And you see one H of here one H is replaced by an alkyl group. So another one, if you see CHCl, it is secondary. Clear? Others?
Ma'am, once more, can you repeat?
Secondary. Okay. Secondary, this is an example of secondary. So how do I know it is secondary? Because this is the carbon connected to the halogen, isn't it? That is connected to how many alkyl groups? 1, 2. 2 alkyl groups are there. And generally we can say CH, X is the halogen, R. So 2 alkyl groups are connected to the carbon, which is connected to the halogen. It is secondary. Understood?
Yes, ma'am.
So that is, so Prashant, is it okay? Prashant? Okay, so now going to tertiary.
Ma'am,
So
example for the secondary, ma'am.
secondary I wrote in CH3, CH, CH3, Cl. This is secondary, isn't it?
Yes, ma'am.
And what is the name of this?
Mm.
Can you name this?
Ma'am, dimethyl.
No.
No.
Are you
Ma'am,
back?
2-methyl
To me?
ethyl chloride.
No. Anyway, nomenclature we are coming. This is, if you see, this is a chain. 2-chloropropane. That is IUPAC name. Otherwise, this group, this group,
Chloroethyl.
huh?
2-methyl chloroethyl.
No. 1, 2, 3. This is the chain. 1, 2,
Chloropropane.
2-chloropropane. That is the IUPAC name. Okay? General name, this group in a CH3, CH3. This group is called isopropyl group. This is common name, not IUPAC. I think I told you last year. This is isopropyl group. So common name is isopropyl chloride. Understood?
Yes, ma'am.
Anyway, nomenclatures we are coming. So this is secondary. Now tertiary. Tertiary, can you guess and say? There will be a carbon containing halogen. How many alkyl groups will be there? 3. Any 3. This is tertiary alkyl. This is the name will be how many carbon? 1, 2, 3, 4. Tertiary butyl chloride. So in all these cases, the carbon is sp3 hybridized. So the first classification is primary, secondary, and tertiary. Understood this? We'll go ahead. Answer, children. Any doubt? You can ask. So we will go to the next classification. Allylic halides. This is the next classification. Allylic halide. So allylic halide. So you should know that what is an allylic halide. Easy way is you will write propene, right? This is propene. and one hydrogen is removed by chlorine. This is allyl chloride. Okay, write it down. Understood? So you can write, this can come in this way also. You can write both ways. Both are the same. This can come here, this can go there also. Both are the same. Got it? So if you do not remember the allyl chloride, you can write a propene, and this one, not that hydrogen, CH3. This hydrogen is replaced by chlorine. It is allyl chloride. Okay.
So, ma'am, so for that compound to be allyl, there should be a double bond.
Yes.
Okay, ma'am.
Okay. Allyl, vinyl, and all double bond will be there. Okay. Clear, children? So I will write again that allylic halide.
Ma'am.
Yes.
Ma'am, why alkyl name?
Why?
Alkyl name, ma'am.
That is the name. It is a common name. Name only it is given to that. How we are giving alkyl? Like that one name. Alkane, how they give. It is the name is that. Okay?
Yeah.
The other way around I wrote. Okay? This is allyl chloride. And here, so this way also you can represent, isn't it? This you understood this way of representing CH2. We don't write CH2 here, C here. CH2 double bond CH, CH2 Cl. Isn't it? So here you have to write CH2 Cl. This is allyl chloride. Okay. Now the question. They don't ask you to write the classification and all. They will ask you. They will give you different haloalkanes or halogen compounds and ask you to identify which is allylic. This is the point. You will write down and keep the point. So how to identify? They give different compounds and ask you to identify which is allylic halogen compound. So how to identify? You will see the double bond and a carbon containing double bond you will see, and the halogen will be next to the carbon containing double bond, then it is an allylic halide. Write it there. Understood? That will be the question.
Ma'am, can you tell once again?
See, the question will be, they will give a number of, okay, one more example. This is the board question. So, these two are examples of allylic halides. Okay, allylic type of halides. The second one is not an alkyl halide or aliphatic halide. Still, they can identify which is. So here, this is the carbon connected, and here the double bond. This is the carbon containing double bond. So the halogen is next to the carbon containing double bond. Got it? So here, this is the carbon containing double bond. Halogen is in the next carbon. Then it is allylic type of halide. Understood?
Yes, ma'am.
All the children? This will be
Yes.
the question. From
Yes, ma'am.
classification itself, question is coming. Any doubt you can type or ask in the mic. Why your mic is, could you repeat? Okay, Abhishek. So this is allylic means how do you identify? You will see that here it is a halogenated compound. Halogen, the carbon containing halogen is this. and the double bond is not on that in the next. Or in other words, halogen is connected to the carbon which is next to the carbon connected to double bond. This is a double bond, isn't it? Not here. In this, if halogen is there, it is not allylic. Next carbon, the halogen is connected, it is allylic. Now understood? Prashant, I just explained. An allylic means here the halogen, the carbon containing halogen is this one. Double bond is not on this. It will be in the next carbon. Then it is allylic. Okay? In this case also, even though it is an aromatic halogen, this compound was asked. So here the carbon containing double bond is here. Here no halogen, no, it is not there. It is halogen is on the next carbon. Then it is also an allylic type of a halogen compound. Is it clear now? Prashant?
That carbon has one valency left, right?
Carbon has?
One valency left in the benzene ring.
Here this carbon?
Benzene ring, ma'am.
Oh yes. Here benzene ring here. What is it? This
Carbon.
1, 2, 3, 4. This carbon.
No, the top one.
This one.
Yes,
This one. 1, 2, 3, 1 H is there, no? Because it is not benzene. Benzene, it is C. What is the difference between benzene? All are CH, 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 CH. This is here, 3 double bonds are not there. So I will draw cyclohexane. CH2, if double bond is there, CH2. CH2, CH2. Okay. So in this case, here these two are having H. Here and all CH2, CH2, CH2. Here CH2 was there, one H is replaced by Cl. Now valence is 4. Clear?
I'm sorry, I was getting confused with something else.
Now you understood? No?
Got it, ma'am, got it.
Okay. So that is it. The question will be a half mark or 1 mark question to identify the allylic type of halogen. Is it clear?
Yes, ma'am.
So this is the classification. Another classification where the carbon connected to halogen is sp3 hybridized benzyl halides. Benzylic. Benzylic. So this is benzene. Last year I told you, if one hydrogen of benzene is removed, you will get it. What is the name of this group? C6H5?
Phenyl.
Phenyl, very good. Who is that? Vishnu Priya?
Ma'am, Rutsi.
Ruchi, good. So phenyl group. If you remove this, last year I was explaining to you. So that is benzene. This is toluene. If I remove one hydrogen, this is toluene, isn't it? Toluene. If I remove one hydrogen, what do I get? Which group I will get? Anybody remembers? This, can you see this?
I'm not visible.
Not able to see, okay. Which compound is this? Name of this, toluene, isn't it? Toluene. If I remove one hydrogen from this, which group is this? Benzyl group. Benzyl. So don't get confused. You may be thinking from benzene, one hydrogen is removed, it is not benzyl, it is phenyl. But from toluene, one hydrogen is removed, it is benzyl group. Clear?
Yes, ma'am.
So, benzylic halides, that is our topic. So, this This is a benzyl group. In that any halogen comes, it is a benzyl halide. This is the second one. So and here also, if you see the hybridization, 2H means it will come like that, all single bond. Hybridization is sp3. So this is the second. Okay? Clear?
Yes.
Okay, others, any doubt you can ask. I will repeat this. Let me see the any doubts are there. Benzyl group. Okay. 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 So look, see, we did the first part, the classification, and there the first classification was compounds containing, depending on the number of halogen atoms. That was easy. The second one classification was the based on the hybridization of carbon connected to the halogen. So there we learned two, allylic and benzylic. Okay, so and then three we learned: primary, secondary, tertiary, allylic and benzylic. And I will explain, any doubt you can ask, and then if it is clear we will go to the next classification. So the first one is the primary, secondary and tertiary. So primary means the carbon connected to, we have to see the carbon connected to the halogen, and that carbon is connected to only one alkyl group, then it is primary. If that carbon is connected to two alkyl groups, it is secondary. Three alkyl group, it is tertiary. And another way, see, the carbon connected to the halogen, except the first case, methane CH4, that is why that is CH3Cl. Otherwise, all the CH3Cl is also a primary alkyl halide. Otherwise, all the primary alkyl halides, the two hydrogen atoms will come. So it will be CH2Br, CH2I, and then only one alkyl group connected, it is primary. And secondary, two alkyl group connected, and CHCl, CHBr, CHI, then it is secondary. Tertiary, three alkyl, so that H also will go, isn't it? So no H will be there. Instead, three alkyl group and one halogen, it is tertiary. Now the next one is allylic. Allylic, I told you, you have to write the propane, you write like that, CH3, CH double bond, CH2. Then one hydrogen from CH3, not from CH2, then it is wrong. One hydrogen from CH3 is replaced. So then it will be CH2Cl, then comes CH double bond CH2. That is allyl halide. And I told you the question will be, they will give a number of halogen compounds and ask you which is allylic. So how do you identify? You will first see the carbon connected to the halogen. And the double bond is not on that carbon, double bond is on the next carbon, it is allylic halide. Okay, then second one is benzylic halide. So you should remember that benzene is C6H6, and if you remove one H, it is phenyl group C6H5, and that is not benzylic. Benzylic, you have to take toluene on the benzene ring CH3. And if you remove one hydrogen, it is C6H5CH2. That is benzylic halide. Is it clear this much?
Yes.
Yes, ma'am.
Okay, so now we will go to the next classification. This classification is based on the carbon connected to the halogen is sp2 hybridized. That means there will be a double bond on that carbon, sp2 hybridized carbons. Okay, so I will go to the board. So here, vinyl halides. Vinyl halides. Okay. So vinyl halides. So like allyl halides, we took propene. vinyl halides, we take ethene. And one H is replaced by Cl or halogen. This is vinyl halide. All of you understood? So for allyl halide, we took propene, remove one H from CH3 and put a halogen. In vinyl halide, you write ethene and remove one H from any one carbon. Both are the same, ethene, isn't it? So this is vinyl halide. Vinyl.
CH.
Take ethene, remove one H and put a halogen. It is vinyl halide. Clear?
CH.
Ma'am,
What?
CH2 double bond CH.
Ma'am, that CH2 one hydrogen will be removed, right?
Yes, one hydrogen should be removed. Okay? So this is vinyl. And they will ask you like, so in the case of aromatic, this is clear? So we will take an aromatic compound. Similarly, aryl halides are also examples. So how do you identify vinylic type? You will see the carbon connected. The carbon connected to the halogen, there if it is a double bond. In this case, see, this is the carbon connected. The double bond is on that carbon, then it is a vinylic type. Got it? Understood, children?
Ma'am, could you explain that once again?
See, allylic means the carbon connected to the halogen, the double bond was on the adjacent carbon. This was allylic. CH2 double bond CH. No. Isn't it? Or in this way also we can write, then it is easy for you. This is the difference between the two. Here, the carbon connected, this is the carbon connected to the halogen. The double bond is on that carbon here. Double bond is on that carbon. So vinylic. In this case, the double bond is not here single bond. This carbon is connected to a single bond. Next carbon is the double bond. Then allylic. Understood? This is vinylic.
Got it, ma'am.
Clear, children?
Yes, ma'am.
Others?
Yes, ma'am.
So that is, they may, like allylic, they can give you any compound and ask you. Okay? And so how do you find it is allylic or vinylic? You will see the carbon connected to halogen. That carbon is connected to a double bond, it is vinylic. If the double bond is on the adjacent carbon, it is allylic. Clear? So now the next topic is nomenclature. So we will go to the nomenclature. Nomenclature, I will take compounds and then straight away we will do, because IUPAC nomenclature already you learned in 11th standard, right? So I can take directly the rules, all of you know. You have to select the longest continuous chain containing the functional group, isn't it? And the substituents will be numbered. And you remember, so I think I can directly take the compounds and we will start with naming. Is it okay?
Yes, ma'am.
Okay, so we will take the compounds we will take. So you can see the board. So we will first select the longest chain containing the functional group. Functional group is halogen. And you will number from the end giving less number. 1, 2, 3, 4. So this end, the carbon containing the functional group is taking number 2.
Ma'am, 2-chlorobutane.
Ah, yes. 2-chlorobutane. This is the first one. Okay. If you are not following, you would say second one, CH3 tries CBr. And for this, when this type of compounds come, you expand. CH3 thrice means this carbon, 3 CH3 groups are connected. CH3 and Br. Now correctly you can write the name of the compound. Now we have to select the chain. If I select this chain, how many? 1, 2. So this is not the chain. If I connect this chain, 1, 2.
Ma'am,
Uh,
ma'am, 2, 2.
wait, let me explain. So the chain is not this chain. You have to select this chain. That is why I said expand. If you look at this, you will not understand. So this is chain. 3 are there. So 1, 2, 3. It is 2.
Ma'am, 2, 2 bromo methyl.
No. Wait. 2 substituents are there. One is the functional group. Here on the second carbon, 2 groups are connected. One is the functional group bromine, one is the methyl group. When in any carbon 2 groups are connected, you have to write it in the alphabetical order, isn't it? Anyway, this is so here in this case it is a bromopropane. We are learning the halogen compound, isn't it? It is a bromopropane.
Ma'am, what about the CH3, ma'am, then?
CH3?
That is attached on this side, ma'am, the CH3. On the second carbon.
Oh. One more is there. Compound is wrong. CH2, isn't it? Okay, anyway, this compound I wrote, you say. In this compound, one more is there, isn't it? Okay. Compound is wrong. That is why. Okay. So, the compound is CH3 tries C. One CH2 is also there. Okay. So now we will expand this. CH3, 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 CH2, Br. Okay. So this is the chain, isn't it? So 2, 2 dimethyl, 2, 2, 2 methyl groups are there. Dimethyl bromopropane, 1 bromopropane, isn't it? So this is, but then we have to arrange according to the alphabetical order. The substituents, the one is bromo, B comes before methyl. So we cannot write like this. Can you see the end part? Name I will write here.
Ma'am, 1 bromo, 2, 2 dimethyl.
You have to say bromo first because alphabetically B comes first. So 1 bromo, 2, 2 dimethyl propane. Clear? Okay.
Ma'am, can you repeat, ma'am?
See, this is compound. Can you see the compound which I wrote it here? I expanded. And I have to select the chain. This is the chain, 1, 2, 3. And the second, this is the first carbon. First carbon is carrying the functional group. First carbon, this is the second carbon. So 2 methyl groups are connected to the second carbon. And so it is a bromopropane. And I have to say that B comes first. So 1 bromo, 2, 2 dimethyl propane. Clear? Methyl means M, bromo B. So alphabetical order, bromine comes first. So I have to say 1 bromo first. Is it clear, Priyanka?
Yes, ma'am.
Okay. 1 or 2 compounds more we will write. Next compound is Oh, vinyl chloride, chloroethene. You know that, isn't it? Next one is easy. Allyl bromide. Okay. Allyl bromide I will write. CH2 double bond CH, CH2 bromide. So common name is allyl bromide. All of you agree? Common name. That is not IUPAC. Isn't it? And can you name this? You name and tell me.
Ma'am, 1-bromopropene.
Any other?
It's allyl bromide.
That is common name, Ruchi, not IUPAC. I'm asking you.
IUPAC name. Okay, okay.
It is
3-bromopropene.
Ma'am, I did not understand why 3-bromo, ma'am.
good question, Amitav. See, you said, Ruchi said 3-bromo, prop 1 name. Amitav said, I will give one number to the carbon containing functional group. And so Amitav said 1-bromo, prop 2-ene. Isn't it, Amitav? Which is correct? This is correct because this is wrong. Because there are two functional groups, bromine and double bond. So when bromine and double bond comes, bromine double bond gets priority right there.
Okay, according to the priority series that we learned last year, ma'am.
Yes. When
All
bromine,
right.
halogen and double bond comes, double bond gets priority because last year we learned that series. In that we said halogens are taken as substituents.
All right, ma'am. Understood, ma'am.
So all of you remember when bromine and double bond comes, then the double bond gets priority. Suppose it is an alcohol, OH comes means OH only will get priority. This will happen only in the case of halogens. Okay, so this is the name allylic halogen and this one. So you can say if CH3 in chlorine is not there, toluene. So common name you can say orthochlorotoluene. Last year we learned, isn't it? Isn't it? So
Yes, ma'am.
IUPAC, either you can see some names we can retain in IUPAC, even though toluene is a common name. See, this last year we learned. This is toluene, right? And IUPAC name, if you say applying the rule, it is methyl benzene. That is the IUPAC name, methyl benzene. We can say toluene also. And so here, this is the compound. We can say that way also. This is the compound. And so we have to give priority here. Chlorobenzene. We can say 2-methyl chlorobenzene. Isn't it? Halogen is getting priority over alkyl group. Okay? Is it okay?
Yes, ma'am. Understood.
So the other names you will go through and tomorrow you will ask me if there is any doubt because it is already 10 o'clock.
Fine, ma'am.
Wait, don't go.